Hey everybody, this is Larry. This is day 16 of the advent of Code 2024. There are about 10 days to go. I don't know why I said about, there's exactly 10 days to go. So yeah, with a minute to the 16th day, let's go. Hope everyone's having a good weekend and all these things. Yeah, I mean, yesterday I feel like I ran out of gas a little bit as a result of just doing too many problems during the day, or like not even during the day, but just like right before. But I did get some points, which is always nice, so we'll see. As usual, I'm going to transition to this so you could kind of see what I'm typing and everything. And yeah, and hopefully we'll be good to go in about 45 seconds or so. Hope everyone's doing okay. Yeah, yesterday's problem was fun. I don't know. It's one of those things where like it sounds scary and it's not easy, but I probably could have done it better. But it is what it is. It's fun. Today I went for a 6 mile run, so I'm a little bit tired, but yeah, we'll see how it goes. We have 20 seconds to go. Ooh. Let's go. Let's get ready to rumble. I have no more things to say, but yeah, the explanation for the prompt and my solution will be toward the end after the live portion, so definitely check that out. We have 4 seconds to go, so feel free to use the chapters on these things, but let's go. Oh, another grid thing, maybe. Okay. Is there a start thing? Start. Okay. I feel like people are already finished. What are you doing, Larry? This is a type part 1. I wonder what part 2 will be. Oops. Some yeast. I need to be better about it. Yeast is going right. Okay. Oh, facing east is Nope. Okay. Oh wait, that's not right, is it? Okay. Nope. Nope. No. 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 Do. 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 Silly Larry. Okay. Otherwise, we can turn 4,000, right? Okay. This is a typing contest, but I'm not doing that well in the typing. Come on, Larry, you have to remember the distance. Okay, YOLO. 283. People are too fast on the typing. Maybe. I mean, it is Daisha, so it's possible people already have it written, but it's still not great. I still haven't looked at it yet. I take too long to copy and paste. Okay. I mean, okay. Well, I mean, this isn't so bad, but I don't think I have a chance to do it fast enough. definitely not fast. Yeah, okay. I think that's fine. Sec4 is weird. That's actually unexpected. Okay, so it's cycling, but why? Did I spell something? Did I do something wrong? This is wrong. I copied and pasted the wrong thing. It happens. Oh, I'm just dumb also. I knew that I wanted to do this, but I forgot. Part 1 is wrong though. Oh no, it's right. I forgot the 2 examples. YOLO submit 76. Okay, not so bad. But I mean, I feel like part 1, if it's a different year, I would have gone top 100. I don't know. 283 is kind of slow, but still. Part 2, I had to debug a little bit, which was a little bit silly. Silly mistake. I watched what I wanted to do. It's one of those classic examples where, like, in my head, I was juggling a couple of ideas, and then I was juggling a couple of ideas, and then I wanted one thing to do 2 things, and then that's why I got infinite stack, because I knew that I don't think actually, honestly, I don't think that's an infinite loop. But I think it's just I think it's actually not an infinite loop, maybe, but it's still a very expensive loop. Actually, this looks like an infinite loop, though. Honestly, so I don't know. Actually, something is wrong with that. I think maybe I just got lucky on the code. I don't know why this would be the case. I mean, lucky I don't have to debug, and we got a little bit lucky. Even though I almost did not submit because I forgot that this is one of those problems with 2 example cases. So like, and I looked at the wrong one. I said 64. It sounds a little bit dubious. But 45 seems okay. So I don't know. I mean, even if it was wrong, I could have debugged it, but I think I'm happy about it. it's just like a variation of but that shouldn't work though. I mean, I didn't memorize, so it should have taken a long time. Maybe there's just a lot of paths, but that doesn't make sense with what I'm seeing here. Why would it go from like previous? Doesn't make sense here. 13101. Like if we don't have this, then I want to say print xytr. Like I don't know why it would actually be infinite loop. Yeah, I mean it crashes. And it does look like an infinite loop that we kind of got a little bit lucky on, because that doesn't make sense to me, honestly. Why that is. Because there's no zero cost. I don't know why I would have got, honestly, I don't know why I would have gotten a top 100 on the part 1, only because Dijkstra is one of those things that a lot of people have pre-written code for, and I typed it from scratch, right? So I don't know. I mean, and not even pre-written, right? Like we've done Dijkstra, well, you didn't need Dijkstra, but I think people could have done Dijkstra earlier this advent of code, right? So as a result, I think it's not that impossible. I think for me, right now I'm upsolving, and then we'll do the explanation afterwards. Because or not upsolving even, just like I think I got a little bit lucky on the answer, but I think something about the setup is wrong, and I'm trying to make sure that I fix it, because I'm not happy with that, honestly. There's only one thing. I mean, we could maybe even just print the entire pref. But why would that go back? Like, it's just going back and forth, and that doesn't even make sense. Do I mess this something up? Like, I mean, I'm glad that things work, but I don't know why it would get stuck on 13.1. Does it work for the test? No, that was the test case, so that's actually good in the sense that I'm able to look at the test case. 13.1, is it the first? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 1. Okay, so that is the first cell. Oh, that's why. Okay, I see why. That's actually a very silly mistake. It's because I didn't initialize the first thing, so I pushed this here. But what I also needed to do was actually two things, right? This is actually a very sloppy implementation as a result. I actually forgot to do this. I mean, it doesn't change the result for whatever reason. I mean, I know the reason, but it's just because you'll never need the optimal results never go back to the first place, but that is actually very sloppy, and I see why that yeah, that is actually very bad. Okay, so that's what I want. Okay, well, it's still wrong, but I think this is more of what we want. I said it wrong. I don't need the distance in the thing, that's fine. Okay, there you go. So okay, so that would have been way more confident, because I didn't think I need this. I mean, okay, so I actually did. Well, depending on the input, I do need this because it would actually count the number of branching, and the number of branching might actually be really slow. But like 590, right? So it actually wasn't that bad for whatever reason. Or like the input is just not as strenuous. So if I had gotten the base conditions correct, I wouldn't have need to fix it, but got a little bit lucky there. And I got lucky on this gone thing only because we don't need to go back to the first cell, the starting cell. And I mean, this is the edge condition on the initial cell. Anyway, let's go over the solution real quick. I mean, honestly, it's not that interesting of a solution in the sense that it is a textbook solution, right? My code may not be textbook though, but yeah. Okay, let's type it on screen. Yep. But basically, the first part is just parsing, right? And probably we could even do a little bit better at this point, like in terms of having better libraries, because Someone told me that we've been like doing 4 or 5 grid problems in a row or something like this. I don't know what it is, but yeah. But the rest is just a very standard implementation. I wouldn't say it that way, but it is an implementation of Dijkstra's in either case. Maybe it's not standard, but it's just gonna be cranking it out. And again, this actually has that mistake that I didn't fix from part 1, right? Actually, and I'm a little bit lazy on the talking. I didn't even talk about it this much. But yeah, the key idea from here is that, and if you're not well versed in Dijkstra, you might miss it if you just can't focus on the X and the Y, is that you can add an additional dimension where the direction you're looking is a dimension, right? Or is, yeah, it's a step or whatever that you can take. And of course, there's only 4 direction that you can look at per cell or face per cell, so it's going to be at most 4 times n, right, where n is the size of the input, which is the grid, which is r times c, right? So which is fine, right? So yeah, so that's basically what I have here. I have sx, sy, starting x, starting y, and then the starting thing. And the directions here may look, I don't know, random, but it's actually, you know, I typed it manually to fix this of the yeast. Yeast has to be the first one to match, so this yeast has to be first one to match the 0. The other ones, well, I mean, I wouldn't say the other ones don't matter, but it's just whether you turn left or right first doesn't matter. But of course, if you turn twice, you should be facing west, right? So that's basically the idea. I think the way that I did is that this is actually south. You know, I think I said north. I don't know if I said north during the live commentary or not. But this is the thing. The key idea here is that if you +1 or if you turn +1 or -1, you're gonna match the turning, which makes the coding a little bit easier. And fewer if statements, and that's how I kind of handle it. So maybe it's not that standard, but it's just something that I take for granted for sure. But here is the states for the Dijkstra heap, right? With dr, I don't know what the dr. I think it's just meant to be direction, but then like I will use d, so I don't know, terrible names is what it comes down to. But yeah, so xy in the direction I'm looking at, and d is just the distance. In Python, the heap is a min heap, so we kind of have this as the first element to use for the distance, right? That's basically it. Yeah. And then we have this thing, which today I'm not going to go over, but at least not in detail, especially on admin of code, because I think you're given more time, so it shouldn't matter too much. But the TLDR you want to look up is that a lot of Dijkstra algorithms in textbooks, they assume that you have a heap that you can call a function called update cost or something. It depends on the textbook, I suppose, but there's an update function, but we do not have that in a standard heap thing, so we do something that we call lazy heap, lazy removal heap maybe. But yeah, it's maybe for now it doesn't matter. I just say here if we because Dijkstra fundamentally operates on a greedy idea, right? The greedy idea being that when you take the closest thing to you, almost like a frontier kind of way, then now the closest thing to that will be the closest thing to those directions, right? It's a little bit recursive maybe, but that's the idea. But that also means that the first time you relax this will be your best solution. And so I print D and I break, and that's it for the solution. Do I have anything under? Nope. But yeah, and then otherwise there are 2 things that we want to do. One is just move forward. If we move forward, the distance goes up by 1, so I just have nd plus 1. Oh yeah, I kind of missed some stuff. Yeah, so dx dy, the current direction is our dr, right? So we just kind of go up that dx dy, which is we added to x and y for nx is equal to ny, right? So yeah, that's pretty much the idea. The rest is just Dijkstra. If the state is greater than the, if the best known distance, which is starts at infinity, that's my convention anyway. If it's greater than your new distance, then we set it as the new distance, and then we put it in the heap for relaxation in the future. So this is to move forward. And then the other thing here in this one is turn left, right? And as I said, when you make it so that the indexes are next to each other in this way. If you plus and minus 1, mod 4 to make sure that you wrap around. This is going to be your new direction. So I also just do -1 1. Yeah, and if the distance, if it improves on the distance, then we push into the heap to get to get relaxation in the future. But of course that costs 1,000, so that's basically it. And that's it. That is in theory is a standard dice drill. There are a couple of things, and in terms of just like implementation detail, just reading it out loud, I guess there are a lot of things that I take for granted for sure. Whoops. So hopefully this is helpful. For part 2, yeah, this is my part 1 in case you want to like watch it or whatever. For part 2, it is going to be very similar. I mostly copy and paste most of this. The only thing that I did differently is this idea of previous, which, yeah, and basically it is saying yeah, I mean, so basically for part 1, we're trying to find the shortest path where the cost is the cost of walking forward and turning, right? So some combination of those. And as a result of this shortest path, you can actually construct something called the shortest path spanning tree. Of course, that actually, technically speaking, won't help you because the spanning tree, by definition, is a tree, and as a result, it will only give you one path from each one. But if you kind of expand it a little bit so that you can go to each parent, yeah. So the idea here is that, yeah, you try to remember the previous step that got you here, right? And what I mean by that is that we call that dice drill. Again, it is going to be a greedy algorithm, right? So you kind of relax things along the way. And when you relax, or when the node relaxes, you may relax too. I don't know. You should. Why not? It's Sunday. But yeah, when the node relaxes, then the previous, the way you fill this out, the previous things will allow you to kind of reconstruct a path. If you can, and if you, the only thing is that if there are two paths that leads to the same, or two paths with the same cost, then it gives you two parents, and so you have to kind of visit them in a way. I could draw an example. Hang on. I don't know if this is an example that's actually inside in. Oops. I don't know if this is like an example that's in a test case, but just for visualization, right? So let's say you have 4 boxes, right? And you're going, a very simple example, you're going from here to here, right? So then, without, I mean, I feel like it should be understood that if you just go this way and this way and this way, they should be the same, right? And the idea of keeping track of previous, and if you keep track of both of them, is that now, if you kind of okay, so maybe I shouldn't have just drew this, but yeah, but if you kind of draw it out, right, of like, okay, what is the previous thing that went to it, right? So let's say you have a bigger grid. I really need like a standard grid creator, because I would feel like this is like a crime against humanity every time I draw. But in any case, yeah, so let's say there's some like wars, whatever, right? And then like, so we have like all these edges about keeping track of the previous, and we only keep track of the previous if it is the best way to that cell, right? Meaning that, yeah, maybe, yeah, and maybe, right? I don't know, right? And the idea here is that if you keep track of the previous, then you're able to kind of walk backwards from it to reconstruct a path. In this case, though, you have 2 or multiple previous, though. I think 2 is probably the. I don't know if there's you could probably construct a way such that the 3 paths having the same cost, but given the cost of turning, it seems hard to believe. But I don't know, right? But in any case, so most of them will have at most like one or two parent. So then the idea then now It's just that you just kind of go backwards, right? You go backwards, and then construct all these things. And here we don't actually even need the path, right? So that's fine. But let's say you are here and you have these nodes, then you just actually go backwards here and go backwards here, right? And basically now you're going all of them. And if you keep track of the cells that you visited, you're only going to each cell given the direction once. So it's going to be linear in the size of the grid, right? And that's pretty much the idea. So the only difference I'll highlight it here is that I set up a list for the previous path that we can take, set up the array of the previous, and I had this for debugging, but yeah. And then everything here is actually mostly the same, even the exit condition, right? But the thing that is different is that whenever I see a better path, I add the previous to this. Well, technically, I reset it to an empty list, and then I add the current thing, right? So that means that if I'm able to come from here to there in the shortest distance, then I update it to be like, maybe I'll write it out. So update the previous closest distance, right? So something like that. Update the node containing this, right? And so that's part one of that you have to add. The second part is just that if it's equal, that means that there are multiple paths to get to the same node at the same time. So then we just append so that we visit both of them, and that's pretty much it. The same idea with the turning direction one, right? We have a and that's pretty much it. And then at the end, as we said, we can just go and this is path reconstruction backwards, but keeping in mind that there might be branching factors, but that's okay. Like I said, as long as you kind of keep track of thing, it should be bounded. And it turns out that in this problem you don't even need to. The exponential explosion does not go that high, I suppose. So you don't even have to do it. But in the general case, that's probably what you would have to do. And that's pretty much it. Let me try to put more of the relevant code on screen. I guess I can fit everything on screen. Actually, I guess this is most of it, really. Yeah, and that's pretty much it. Yeah. The complexity is all Dijkstra's algorithm, so you can say it's relog yi. There's a relog v version, but we're doing the lazy heap, so it's going to be relog yi. Keeping in mind that yi is at most 4 times v, so it's going to be over relog v anyway, where v is the number of vertices, and the number of vertices is r times c times 4, as we mentioned before. So still linear, of course, or linear in the input, but so it's going to be relog v, which is not linear, of course. But I meant like v is the number of vertices is linear to linearly proportional to the input, but the end result complexity is relog v, right? Or relog y, if we want to be precise. But like I said, they're only at most, actually not even 4 edges. I'm so used to grid and saying 4 edges, right? Actually, no, there's 4 no, this is different. 4 because 1 for each direction, so that's the number of nodes. But the number of edges is actually 3 times v. So there's 4 times v number of, well, I guess 4 times v is 4 times r times c is the number of nodes. 3 times v is the number of edges. Very imprecise today, but now hopefully a little bit more precise. But yeah, roughly, of course, there's an upper bound, not, because you can have walls and all these impossible edges or whatever. But that is all I have for today. Let me know what you think. Yeah, let me actually show the thing a little bit. Today we did okay. Part 1, I'm actually a little bit surprised that part 2 people didn't do as well. But I'm not gonna complain. I got 25 points. Probably could have been a little bit faster if I had pre-written Dijkstra or something like this, but I have enough pre-written stuff. I don't know. I'm not really that worried. I was definitely a little bit slow in part 1 though. But I guess I'm still surprised that part 2, like, if people got it so fast, they should be able to get part 2 quicker. But I don't know. It is what it is. I'm not gonna complain. That's all I have for today. That's all I have for this video. That's all I have for Advent of Code Day 16. And thanks for watching. hope to see you tomorrow. Stay good, stay healthy to your mental health. Yeah, goodbye.